So, quick pivot. We want to bring up Bilal, partner at Lux Capital, to speak on the investment side of all this from a technological perspective. Bilal, thanks so much for being here. Appreciate it.
Thanks for the invite. Can you guys hear me? All right, something quite different. I have nothing to sell. In fact, if you have something to sell, I have money to invest.
Yeah, so good. It's really smooth.
My name is Bilal Zuberi. I'm a partner at a firm called Lux Capital.
So
we're an early-stage venture capital firm.
I was able to get through all your questions.
Manage about $2.5 billion, investing in today, up to date, maybe 120 plus companies. We've written checks as little as a few $100,000, and we've written checks as large as $50, $60 million. Venture capital invests primarily in three big areas. One area that you would understand very well, being at Consumer Electronics Show, is consumer products. Now, a lot of the electronics products, by the way, actually don't really get venture capital, but consumer products include things like Snapchat, you saw. Another area venture capital invests in is enterprise technology, looking for the next Salesforce, enterprise SaaS software solutions. That's where majority of venture capital goes, with the little exception of course, biotech, which is in its own world. However, when we think of the history of venture capital, more importantly, the history of technology, and you look at the arc of history, I think we will probably remember those kinds of companies less. We'll probably remember companies that led to the creation of supercomputers, led to the creation of computers in your home, in your lap, in your hand, in your pockets, in your ears. We will think a lot more about electric cars. We'll think about rockets and satellites. That's really the technological revolution that has happened. In fact, today, over the last 10 years, the world has completely transformed, where the entrepreneurs that I call it Silicon Valley, but really Silicon Valley-esque entrepreneurs all around the country and all around the world really believe that it is possible to turn science fiction into reality. Okay? We're not only launching satellites into space and have rockets, we're actually landing them back on Earth. SpaceX, which was a crazy idea, doing something that governments are having a hard time to do elsewhere in the world, but a private company doing that, is unbelievable. We have Tesla, which was a joke in some ways among the automakers 14, 15 years ago when they got started. Today is worth 55% more than General Motors. It's $86 billion when I checked last night. Right? We have companies like Oculus that are bringing virtual reality to our world and having us effectively transported into another world. We have companies in our own portfolio. Johnson & Johnson acquired Auris Surgical Robotics, minimally invasive surgery, for $6 billion, and the company did not exist 5 years ago. Right? So the entrepreneurs today are fully aware that while there's many ways of making money by doing small incremental technological improvements, really it is possible today to change the world in very dramatic ways. They are shooting satellites into the space. There's more satellites that have been put into the space in the last 2 years than have been put into the entire history of humanity. We used to have satellites that could see down Earth and take a picture maybe every 6 months. There was an attack on a US air base yesterday, was it? Right? And one of our portfolio companies, Planet Labs, already has available for you, consumers, images that are real-time images of what happened on that airbase when the missiles landed. Okay? We have companies that have drones in the air that are autonomous. We have companies that are printing metal. So all the metal products are no longer machined, but they're actually printed. We have companies that are doing human brain reading to do brain-computer interfaces. You know, computers are really fast. However, our input into those computers is still as fast as you can type. That's going to change. We have seen in our own world, I grew up learning how to type on a keyboard. Then came the iPhones, and now I'm like, click, click, click. I can do it really fast. My kids are growing up talking to their computers, right? When you show them a keyboard that you and I grew up with, they're like, what is this? Where do you put it? Do you fold it and put it in your pocket? How do you take it with you? It is a completely different world that we live in. That's the future that we invest in. So what are the big things, if you look back in all of this, what are the big things that have happened that, you know, I believe in the last 5, 10 years have completely changed how we think about innovation and what is possible? And you know, in hindsight is 2020, but I think of it as 3 big things that have happened. First, miniaturization and commoditization of sensors. You know, some people called it the peace dividend of the cell phone wars. we are able to now get extremely cheap sensors available that we can make devices out of. Soon we will be seeing peace dividends of the autonomous car wars. So all those sensors that we talk about, the LiDARs and the radars and the cameras and all kinds of equipment that goes onto autonomous cars that you can see here at the CES, this is all going to get commoditized. Right now they used to be $10,000. They've come down to maybe $4,000, $3,000, $2,000. They're going to come down to $100. DJI is, I think, showing a LiDAR you can add onto a drone and go and fly. Okay, so commoditization of sensors is happening. The second thing is very easy, very rapid, and very ubiquitous connectivity. We are all connected to each other. We're all connected. All sensors are talking to each other. So we do no longer have point sensors that are collecting data and we're trying to make judgments based on those sensors. We now have a swarm of sensors that are all talking to each other and sharing data with each other and calibrating in real time. And third, if you have this ubiquitous, enormous amounts of data being generated by sensors, we have now developed machine learning, artificial intelligence, and computing tools to be able to use those and do interesting things with them. You put all this together, you close the loop, you have automation systems, you have autonomous systems, you have autonomous cars possible, you have autonomous drones possible, you have brain-computer interfaces possible, you have robotics possible, all kinds of things are possible because of those three innovations. Now, a lot of the times I get asked, when I'm up on stages like this, I get asked, what's the future? What is science fiction today that we can imagine coming to CES maybe in a few years from now? And my answer, and you know, we've talked about this as a fund quite a bit, is we actually don't know. But there's a way to look at that, and I'll tell you a story of how material science and electronics and hardware and then software all connect to each other in an arc that's linked together. Now, there's 100% surety that Lux Capital, which the firm that I represent, will be investing in very interesting things that many of you will consider to be science fiction. And the reason for that is our mandate. My mandate is not to do incremental stuff. My mandate is find those breakthrough ideas that look crazy, but be prepared enough that you know, is it really crazy? Or is it crazy that, wow, if it's possible, it will change the world? 0% knowledge of what it is because the future is not written yet. It is there. But here's the 100% guarantee that I have, which is that the next big idea will be found at the cutting edges of where people are today. Let me explain that to you, what that means in the life of a venture capitalist or in the life of technologists looking for the next big thing. About 8-9 years ago, we got excited about an area of material science called metamaterials. These are unique materials that have unique properties, and really what people talk about what they can be used for at that time was invisibility cloak, okay? Now, that's a great idea for science fiction. It's great in Harry Potter and whatnot, but the commercial reality of that was not there. We did a lot of work on it. A lot of us have very significant technical degrees to be, what else can you do with it? And we came up with an idea that we invested in and Bill Gates invested in together to create flat panel antennas for satellite communications. If you sit in a JetBlue and you get internet, it's because inside that JetBlue, there's actually a dish which is tracking satellites. There's literally a dish that's moving inside. You don't see it, but it's there. And that's why it cannot do station keeping at times, and you lose connectivity, and then you get mad, and you're like, what the heck? That needs to change. Now, you can change that by creating a solid-state antenna that's always able to do station keeping. Metamaterials, we invested in this company called Chimera that's doing that to provide very fast gigabit Ethernet to your moving systems. You could be a plane, or it could be your car. Okay? If you're going to do vehicle-to-vehicle communications, you're not going to do that on cell phones where I can barely talk to my kids while I'm in here. You're going to do that on fast internet. So Chimera, we invested in that. It's a material science-based innovation. We were talking to them, and they said, you guys need to, we do satellite communications. You need to talk to these guys out of NASA. They've been working on these satellites that are the size of a shoebox. Now, a satellite used to cost $300 million to make, till today it does, and $300 million to put it into the space. And these shoebox satellites, they cost like a couple $100,000. You should go see it. We didn't believe it, but we went and saw it, and guess what? That is true. You can now make satellites that are the size of a shoebox and launch hundreds of them at a single time at a cost that is orders, 3, 4, 5 orders of magnitude cheaper than launching full satellites. That's what Planet Labs has done. They have hundreds of satellites in this space that are real time. You go home, you paint your wall red today, I guarantee you that Planet Labs will have an image of it tomorrow that it has been painted red outside, not inside your house. All right? So we invested in a satellite company. It's amazing that venture capitalists are investing in a satellite company. Now, when we thought about that and we said there's going to be a lot of these companies, satellites are going to be launched, we're going from 5 satellites to 500 satellites, there's going to be a ton of data generated. How are we going to process that data? Who's going to process that? Who's the Bloomberg of this data? Okay? And we looked at that and we said maybe Bloomberg is the Bloomberg of data. Then you talk to Bloomberg guys and no, they're not going to be it. And we looked around and we found this one guy who built this company called Climate Corp, which was taking all that data and analyzing it to create insurance products for the agriculture industry. It was bought by Monsanto for $1 billion, and he was creating exactly that. Taking satellite data and figuring out within that satellite data, what is the information contained that I can get insights from. These customers are hedge funds. They want to see how many cars are parked outside Walmart versus Target. Usually they are in the same zip code. So you know, before they announce their quarterly results, who's going to do better than the other. But these are also the firms looking at oil depots in Saudi Arabia to see what is the supply of oil going to look like. These are also the sites that are looking at how is construction happening in China and how many ghost cities might exist there. So we invested in that company. Now, as we were talking to those guys, and we said, that's a lot of compute. How are you doing this? So a few years ago, they said, what do you mean how we're doing this? There's this thing called GPUs, and we do machine learning, AI, it's all automated, and it's all happening on these GPU clusters. And you look around and you say, oh my God, there's really only one company, NVIDIA, that's doing GPUs? Back then, this is a great opportunity. What else is happening there? So we start looking around, we found scientists out of LA, we invested in that company, and within a year, that company was acquired by Intel for $400 million, called Nirvana. Okay? And as that company exited and became a part of Intel. So remember the story now. We started with metamaterials, which is a material science. We went to satellites doing hardware. Then we went to machine learning AI. And then we've gone on to semiconductor chip companies that are doing new generation GPUs. The last thing I'd say in that story is that Nirvana led us to then saying, hey, GPU is fine for doing communications and doing computations in the server scale, but if you're going to do that at the edge, something else is needed. Low power compute is needed. We ended up investing in a company called Mythic, which is doing basically AI compute, but at the edge. The story, the purpose of all of this in my last minute to tell you is that innovations are happening across all dimensions, from material science to chemistry, biology, to computers, in the sense of chips and the things we think about, and then networking and then hardware systems. The good thing is money is available now. The good thing is the entrepreneurs are not scared. They have role models like Elon Musk and others available that they look up to. And the question is, will we be supportive? We mean the grand us. Will we be supportive so that when we come out here to CES 5 to 10 years from now, we're not seeing incremental improvement from what you're seeing today, but something completely dramatic, something completely different. That's what I'm hoping will be happening in 10 years from now. Thank you all.